Okay, so here's a wild thought. What if you could take a picture of something that isn't, physically there? Well, today we are diving deep into a really fascinating experiment that tries to do just that. It's this incredible blend of optical physics and a very, very personal story. Welcome to Between Light and Vapor, the return of Reggie.
So, let's just jump right into the big question, the one that's at the heart of all this. How in the world can you photograph something that isn't physically there? It sounds impossible, right? But that's the central mystery we're going to unpack. To even attempt to answer that, the researchers had to get creative. They built this really unique device they call the Acetate Array. So, let's take a look at how this optical bridge, as they call it, is supposed to work. And here's the setup. What's amazing is how simple it looks. You've got these transparent acetate sheets just hanging from a regular metal hanger, and a humidifier creating this constant stream of vapor. The whole goal here is to create a really powerful optical interface, but with these pretty basic, everyday components. So what's this thing actually doing? Well, the acetate array is designed to use those layers of transparent sheets to create what are called interference patterns. The whole idea is to capture interactions between light, that vapor we just saw, and something the researchers call potential information fields, which is basically their term for a theorized layer of reality that we can't normally see. Now, the way this array is designed is super deliberate. The acetate sheets are actually cut in different sizes, and there are a few really key reasons for that. First, it stops the edges from overlapping, which would create these big, distracting reflections. Second, it creates this cool tunnel effect that actually guides the light inward, deeper into the array. And finally, that helps to diffuse the light, making sure the layers in the back get a much more coherent beam. It is all about controlling the light, every step of the way. But you know those acetate sheets? They're really only half of the equation here. The other key ingredient, the one that makes the magic happen, is the vapor. It plays this absolutely crucial role in making the invisible, well, visible. This image really gets to the heart of the whole experiment. The core idea is that when a beam of light passes through that combination of vapor and acetate layers, it creates a special kind of medium, a space where an image can actually begin to form. So how does vapor pull this off? How does it make invisible things appear? Well, think of it like seeing dust particles floating in a sunbeam. It's the same principle. The vapor acts as a light carrier, scattering the photons and revealing patterns that would normally be completely invisible to us. It's the medium that lets us see what might be hidden in the light itself. But it turns out, not all vapor is created equal. The first few experiments used a standard humidifier, but they ran into a problem. It was creating these tiny water droplets that actually distorted the images. So the solution they landed on was to use a dry fogger instead. This thing creates a super fine aerosol, kind of like cold air, that provides a really stable medium without those distorting droplets. It's a perfect example of the scientific process in action, right? You observe, you identify a problem, and you refine your methods. Okay, so we've got the setup and we've got the theory. Now it's time for the moment of truth, the results. Let's actually look at the images of Reggie that they managed to capture in this experiment.
Wow, this is one of the first images they captured, and it is pretty striking. You can clearly make out a human-like face appearing right there in the array. The researchers themselves were really blown away by the clarity of it, and they saw it as a massive breakthrough.
And here's another one, this time with this really cool blue tone. And again, you can see a clear, face-like formation. This is the specific image that the researchers identified as Reggie, the actual subject of their experiment. Now, to really appreciate just how significant these images are, let's put them side by side with results from an older technique. On the left, you've got an image from an old TV experiment. It's just full of static and noise. And on the right, the new image from the acetate array. I mean, the difference in clarity and definition is, well, it's night and day. So what's the big takeaway from all this? Well, the researchers are convinced that this acetate array is a major leap forward in the field of what's called instrumental transcommunication, which is a fancy term for using electronic devices to try and communicate with a non-physical world. They argue it produces images with way more stability and clarity than anything that's come before. Of course, this all brings up a gigantic question. How could any of this even be possible? To try and answer that, we have to take a little trip into the very strange world of quantum physics. Let's look at this theory of quantum entanglement and how it just might explain these incredible results.
Okay, so this is where things get really mind-bending. The theory goes that these images aren't traveling through space to the camera like a normal photo. No, they're supposedly emerging simultaneously, in our dimension and in another one. The idea is that these two dimensions might be connected through something called quantum entanglement. It's this bizarre quantum phenomenon where two particles become linked, and whatever happens to one instantly, and I mean instantly, affects the other no matter how far apart they are.
So what would that look like in this experiment? The hypothesis is that a consciousness in that other dimension could somehow manipulate the light in our dimension. And because of that quantum entanglement link, that manipulation would instantly create an image in the camera. It's a wild idea, for sure, but it's an attempt to use the principles of modern physics to explain something that seems to completely defy our normal understanding of the world.
But you know, beyond all the physics and the wild speculation, this whole experiment has a deeply, deeply personal core. And this quote from Valerie Degree really brings it all home. "I am so humbled and grateful for these images that Reggie and Sonia have collaborated on together. Because in the end, this entire scientific journey is being driven by a very powerful, very human desire for connection. And it leaves us all to wonder, what other bridges can be built between what we can see and what we can only believe?"